Hi everyone, this is Mel, and today we're gonna go through Chapter 16, Summary of Math Method Unit 1 and 2 of VCE subject. So this one relates many concepts about the physical world, like the velocity, the position, and stuff. So let's go through bit by bit. First, where a real-life situation is modeled by a straight line graph. So straight line graph, something like this. Straight line. The gradient represents the rate of change of one quantity with respect to another. So the rate of change of y respect to x. So in our physical world, we have many situations which can suit the graph. For example, if we're pouring water in a tank, initially there's no water, so it's 0. And then as time goes by, the volume in this tank will increase. So it goes 4, 8, and blah blah blah. So maybe it can model by y equal to 2x, where the 2, which is a gradient, represents the change of volume of the water in the tank with respect to the time. So the one quantity here means the volume in respect to another, which represents the time we're talking about. Or it can be decrease and some other situations. Okay, let's move on. The average speed is equal to the total distance traveled divided by the total time taken. So if you run for, let's say, 100 meters, and you take 20 seconds, so the average speed is 100 divided by 20, so 5 meters per second, which is pretty fast. And so we're talking about speed, not velocity. So speed is a qualitative number, and velocity is with direction, so it's a vector. Is a vector, and speed is not, because it does not have direction. It does not specify which direction you're running. So yeah, so next point, for a function y equal to fx, the average rate of change of y with respect to x over interval a from a to b is a gradient of the secant line through this point a FA and this point B, FB. So what it's saying is the gradient, so the gradient of the blue line over here represents the secant line through this point and this point. This gradient. That's called the average rate of change from x equal to a to x equal to b. And in contrast, what about tangent line? So tangent line is with respect to a single point. Not like this. This one is talking about rate of change between 2 points. And tangent line is talking about with single point on the red curve. So for a function y equal to fx, the instantaneous rate of change. So instantaneous means at the point, at the moment, at the point. Its rate of change of y with respect to x at the point a, fa, is a gradient of the tangent line through the graph at the point. So it's saying at this point, what's the gradient? What's the tangent line just passing through one point of the red curve? And the gradient of the blue line represents the instantaneous rate of change of y at the point. And then the position. of a particle moving along a straight line. Specify its location relative to a reference point O. So for example, we have a coordinate system with x and y. So the reference point must be 0, 0, or it can be some other coordinate points. If you take, for example, it's not really necessary. If you take, for example, 3, 2 to be a reference point, then for a point, the pinpoint, let's say 1, 2. So in different coordinates, the red and the purple one, you can have different representation of the pinpoint. So the position is actually depending on the coordinate or the reference point you take. And the average velocity. Now we're talking about the velocity, so it has direction. Of a particle is the average rate of change in position with respect to time in a given time interval. So why is velocity now a vector, but when we talk about speed, it's not a vector? So it's important to know that when we talk about speed, we use the total distance traveled. But in contrast, if we have velocity, when we're talking about velocity, we're actually saying the rate of change in the position. So when we are talking about position, so for this pink point, we're actually taking the vector of the coordinate. So if position is a vector, then velocity must be a vector. Or let's make it more clear, average velocity is equal to change in position divided by a quantity number t. So if position is a vector, then velocity must be a vector as well. And the instantaneous velocity is the instantaneous rate of change in position with respect to the time at a given moment, which we talked about earlier over here. So this chapter relates a lot about the physical world, some physical scenarios, like when you're having a rate of change, which you can modify with a linear relationship. That's what this chapter about. So hope what I'm saying is helping you. Thanks for listening.